Hi, I'm Dr. Todd Daniel, and you're watching Statistics for the Flipped Classroom. Today we're going to learn about how to display our data with pictures. I'm going to teach you the most common types of graphs: bar graphs, histograms, line graphs, even a pie chart. And I'm going to show you one of my favorite and what I think is one of the most useful types of graphs, and that is the box plot, also called the box and whisker plot. We're going to learn how and when each type of graph should be used and how to create each one. So let's get started. There are two ways of preparing our data to present them to the world. The first is using numbers, and the second is using pictures. Numbers might include a frequency table or a mean. The pictures, called graphs, include such things as bar graphs, histograms, frequency polygons, stem and leaf diagrams, and the box plot. All of these are ways of displaying our data. And what matters most is that we display our data accurately, so that people can understand what the data mean. A basic graph is constructed of two intersecting lines. The x-axis, or abscissa, is the horizontal line. Scores from your variable of interest go on the x-axis. Just like a number line, smaller numbers go to the left and larger numbers go to the right. The left is the negative direction. The right is the positive direction. The y-axis, or ordinate, is a vertical line. The scores are plotted from bottom to top, with low scores near the bottom and higher scores further up the number line. Frequency, or the outcome variable, goes on the y-axis. In order to display your data honestly, the y-axis should include the range of possible scores. If you are plotting percentages, for instance, the y-axis should always include 0% and usually range from 0 to 100%. The point at which the vertical y-axis meets the horizontal x-axis is called the intersection. It is the convergence of the two axes that represents a score of 0 on both x and y. This point is also sometimes called the origin. Scores are plotted based on their values of their x and y variables. And each point on the graph is called a data point. Regardless of whether we are creating a bar graph, histogram, or line graph, we will follow this convention. Scores will go on the x-axis. Frequency will go on the y-axis. The specific type of graph that we will choose depends upon whether the data that we are plotting are nominal, ordinal, interval, or ratio level. Your most important obligation when graphing is to display the data honestly. It is possible to misrepresent data even though what you say is technically true. And here is an example of a bar graph showing the effectiveness of abstinence-only sex education. The vendors of this school curriculum claim, quote, "Students who received Choosing the Best were nearly 1.5 times more likely to delay the onset of sexual behavior than the control students at the end of the 9th grade." End quote. Now, assuming that is true, have they accurately represented it in the graph, here recreated from their promotional material? Notice the size difference between their blue success rate and the green success rate of the other program. The green bar is less than half the size of the blue bar. That looks like a huge difference. This program must really work well. But now notice the origin on the y-axis. It's the number 61%. They have made a mistake by not anchoring the graph at 0. Let's see how it looks when the data are displayed honestly. Now the y-axis is anchored at 0. And includes the full range of data. This is the difference from the previous graph. Not quite so impressive when you put it into context. Furthermore, when you compare the blue bars and the green bars from the beginning of the program to the 3-month follow-up, you'll see that they both drop the same 11.3 percentage points. which is to say there are 11.3% fewer virgins in both the abstinence only and the control programs 3 months later. What conclusions about program effectiveness do you draw now? Do you see evidence of massive success, or a program that works no better than a control group? Bar graphs and histograms should, generally, be anchored at 0. They should include the range of all possible values, and they should use a scale that enhances and accurately displays the data. So what makes a graph good or bad? Your first obligation when creating a graph is to display the data honestly. Graphs are bad when they distort data, and this distortion may be intentional or unintentional. Good graphs show the data clearly and in a way that is easy to compare. Edward Tufte wrote the definitive book on graphing, called The Visual Display of Quantitative Information. This book is a classic. It is on Amazon's list of the best 100 books of the 20th century, and it has been called the century's best book on statistical graphics. Even if you have never had an interest in graphing before, you would still enjoy looking through this book. In a section on presenting data clearly, Tufte offers a number of observations about excellent graphs. An excellent graph should show the data honestly, so that the meaning of the data is clear. Avoid distorting the data or creating false impressions about the findings. Present maximum information with minimum ink. Excellent graphs condense large amount of data into an accessible form. Make large data sets interpretable. When your data set is huge, it can become hard to handle. Show off your data with an excellent graph, and everybody will be impressed. Don't distract your reader with chart junk. It's all about the chart. Don't add colors, patterns, cute graphics, 3D. That's all chart junk. Keep it simple. And stimulate your readers to think. A compelling chart is a delight to all. It draws you in, makes you think, teaches you something, and leaves you knowing a little more than you did before you saw it.